Hi folks, I am solving Leetcode's top 150 questions and that's all you need for your coding interviews. So in this video, we'll be solving 973 k closest points to origin. We are given an array of points with coordinates in xy lane, which is nothing but this right here if you can see, and we have to return the closest element from our origin. Yeah, we have to return k closest elements from our origin. They make it easier by giving us this formula of calculating the distance. If you remember this formula from your high school, so to find c, we need square root of this value. But in this problem, we don't have to exactly calculate the square root, and it is given that the answer is guaranteed unique so that 2 points don't collide with each other. Let's take this example here. If you can see, we have 2 points. This is -2 and 2, and this is 1, 3. To calculate the distance from our origin, which is 0, 0, we can use the formula which was given in the question. There are many different ways to solve this. I'll show you the min heap version. So what we will do is we will store the distance, then x and y value, and we can do it pretty much for every element: distance, x and y value. And we will push this value to our heap and prioritize this first element right here. And we can store this as square itself. So 1 square plus 3 square, this will be 10 here. -2 square and 2 square, this will be 4 plus 4, 8. On our final result, we will pop the elements from our min heap. This value here will be popped. We can ignore this value and add our x and y, which is nothing but -2 and 2 here. Until our k is 0, we can add elements to our result. Now let's look at the code. We can start by defining our min heap. It is defined by min priority queue in JavaScript. And what we said was we will take the very first element as a priority. So this means heap will be sorted based on the 0th element. Now let's iterate through our points array and add values to our min heap. Here for distance, so this is our distance, and then we'll add this to our heap. And let's define our result variable. Now let's start from 0 and go up until k to push the elements inside our res. And once we are here, we will pop the elements from our heap. So this will return us our distance, which I can take as underscore because we won't be using it, x and y. And then we can just push our x and y coordinates. And finally, we can return our res. This completes our solution. So for time complexity, so this operation, which is adding an element in our heap, is log of n of, and we are doing it n times, the length of points time. So n multiplied by log n plus this pop is also log of n time operation, and we are doing it k times. So this boils down to big O of n log n. Now let me run this. Oh, my bad. There is a typo. Now let me run this. Yep, it works. I hope you found this video helpful. If yes, you can consider subscribing to this channel. And thank you so much for watching.